Okay, we are going to be going on these first 6 exercises that are basically looking at functions, and we determine whether or not they're polynomial functions. For those that are, state the degree and leading coefficient. For those that are not, explain why not. So what we're going to have really is a discussion, kind of, because now, do you know the definition of a polynomial or polynomial function? Anybody have an idea?
Vertical line test.
Well, a function, right? A function will be defined by the vertical line test. Yes, obviously, right? That's good. But what is a polynomial?
Multiple.
Okay, we'll see. Multiple, poly is one thing that is multiple in, like in English, in colloquial English, the way we talk. But in the terms of algebra and mathematics, it is not. It's more broad than that. Okay, here's what a polynomial is. A polynomial term is x to the power of a non-negative integer. Can you think of that? X to the power of a non-negative integer. So what's an example of a non-negative integer?
2.
2. What else?
5.
5.
100. 9.
7. 100?
3.
3.
700.
Anything above 0.
633.
Okay, Kinsey said anything above 0. Is that right? I said non-negative integer.
Yes. No.
Excluding 0.
Non-negative integer includes 0. So you can have x to the 0 power and qualify as a polynomial. And what happens, you can have just, Kayla, one term in a polynomial, or you can have many. And graphically, what a polynomial looks like is a polynomial function is going to be smooth. It'll be a smooth curve or a smooth line, either one. Okay, so you can have a smooth curve. So if you have a calculator and you can graph and you can look at it, that can give you a clue also. Also, for polynomial functions, what is the domain of all polynomial functions?
All real numbers.
All real numbers. So if you see an exclusion to the domain, any exclusion to the domain, that's evidence of a non-polynomial function. All right? So let's go ahead and work on this one. So for number 1, we have fx equals 3x to the negative 5th power plus 17. Is this a polynomial function or not?
No.
Not. No. For those that are not, explain why not.
Because it has a negative line.
Yeah, because we have x to the power of negative 5. Non-negative integer, right? Or that's a negative integer, excuse me, right? And when you graph this thing, did anybody graph this thing and look at it?
No.
Okay, if you go, I'm going to rewrite this thing. How do you rewrite this as it's going to be 3 over x to the what? 5th plus 17. So is this function going to be continuous everywhere?
No.
No, it's not. Okay, so this will be like if you graph the thing, you'll see where are you going to have your discontinuity at x equals?
So if there's a negative in it, we're just going to put down.
X equals 0. Yeah, no, because of non-integer. So that will be something like that. Okay? Ready to go on to number 2?
Is it no?
So no, yes, no, and because, what Emily?
She's ready to go on to number 2,
Yeah.
is what she's saying.
You are,
Number
okay.
2 now.
Okay, is it 2? Did you say no?
Yes.
For number 2? Yes?
Why did they say
You
yes?
never told
Why
us
did
if
they
it
say
could be a polynomial without it having a power at all.
no? You said if it was negative, then it's
But it's actually like, isn't that actually x to the 1?
Yeah.
So it'd be a positive 1.
Yeah, so this would be yes,
It could be.
yes, and for those that are, state the degree. And so what is our degree of this thing?
To the 1. X to the 1?
The degree is 1, because x to the 1. So degree is 1, and what is our leading coefficient for this?
2?
Leading coefficient is 2. And what you do is you look for the highest power term, and that's the one that decides what it is. Now, is this going to be a Is this going to be an odd-natured function or an even-natured function?
Odd.
Why do you say odd? Odd is right.
Starts low, ends high.
Right, it's odd positive,
Just do opposite of
so Kenzie, this is start low, ends high, right?
Yep.
And we don't know exactly where we'd have to graph it, but starts low, ends high, because that's going to make a difference. So odd positive, odd negative, even positive, even negative. So Emily, remember, she's doing that. You remember that from last year? So you could be a cheerleader this year, doing the odd, even. Right, you're gonna do, Kay, you doing that this year, right? Odd, even. You're not gonna do it.
You should do that for Mr.
You're
G.
your captain. Oh, you gotta give him. All right. I'm gonna try to get others, because I'm trying to get the cheerleaders doing that. Maybe I'm not gonna be successful at it, but I've been successful in the past. So anyway, this one right here, polynomial function or not?
Yes.
Yes, polynomial function, and for those that are, we say our degree is, and what is our leading coefficient?
2.
Equals 2. Okay, so that's going to be number 3.
Do you like the last home game? We might have
For the last home game, okay, that'll be good. That'll be awesome, when more people know about it, yeah. But it's definitely one for it's a pre-calculus one. And I think in Algebra 2 Honors, we talked about it a little bit last year, because I know I saw Will and Emily and others recognizing it somehow. Okay, let's go to this one right here. Polynomial function or not?
No.
Yes.
Anybody say yes?
Yes.
Yes.
Okay, Angel says yes. Say yes.
Yes.
The answer is actually yes. And I'm going to have to explain what this is, because that's not... What we have is 13. When you have a number by itself like this is actually 13x to the power of 0. So a number by itself qualifies as a polynomial, and that being the case is our degree is going to be
0.
degree 0, and also our leading coefficient 13. Very good. You said that even before I could think of it. So that's number 4. And then I have these ones strewn here. I'm going to come back to these in a minute. Let's go to number 5. Polynomial function or not?
Yes.
Yes?
Yes.
No?
Angel said no, so I go
No?
Oops.
And why not?
Because Angel said
It's
no.
like, when you graph it, there's like a break.
There's a break. Okay, so he noticed when he graphed it, so he got graphical evidence.
Because it's square root and negative.
What it is, it's this,
Actually, it has a 3. so
not to the power. See what it is?
You said square first.
To the power. What is this to the power of? Somebody besides Will. To the power of?
2.
11. No.
To the power of somebody besides Will. To the power of?
11.
To the power of 1/3. 1/3. That's what you're going to say, right, Will? Okay, 1/3, not a non-negative integer.
Wait, where'd you get 1/3 from?
That's how you rewrite cube root.
So that's to the power of 1/3. This cube root means to the power of 1/3. So that's why.
But it's still not negative.
But it's not an integer.
But
It's not a non-negative integer.
There's not-
1/3 is not a non-negative integer. In fact, it's not even an integer, right? Yeah. So, but here's what would happen. If we separated this out, I'm just going to do a little bit of a rewrite. If we write this out as cube root of 27x cubed, or if we write this as f of x equals cube root of 8x to the 6th, would these qualify as polynomials separately if we did it this way?
The first one would.
Okay, the first one would. What would we get if we simplified the first one?
27x.
Well, we get cube root of 27, which is 3, right? And then cube root of x cubed, which is going to be x, right? because that would be x to the 1 power, right? And so this would simplify to a polynomial, and this one down here would simplify to what?
2x to the third.
2x squared, actually, right? So separately, each of these qualify as polynomials, but together they don't. And Angel tells us he saw a break in there where it wasn't a smooth curve, right? So that would be that. Let me show you something. I'm going to go back here. This one right here. And what we have here is when you have y equals cube root of x to the 4th power, what is that going to be translated into a rational exponent? That'll be x to the power of what? No?
3 over 4.
It's actually going to be to the 4/3. Okay? You see that? So that's why I put that example right there, so you can kind of think about that a little bit. Okay? Okay, now we are to 6.
I'm going with no.
You going no?
Yes.
I go with Kenzie all times on Tuesday.
Yay.
We'll say yes. Okay, and what is our degree?
What?
2.
Wait, what? Trying to be. Didn't say yes.
And what is our leading coefficient?
-5.
-5. Okay, is this one going to be like, where am I? So this is going to be,
Oh, yeah.
is this one going to be
I gotta see.
odd positive, odd negative, even positive, or even negative?
You need to change.
Odd,
On
negative.
negative.
Good answer, class. Woo!
Woo!
What is that?
Even,
Oh.
even
Even number, right?
negative.
Negative.
Is that negative?
Yeah, even negative.
Even negative. Okay, and even negative does what? Starts low, ends low. Okay, and if you graphed it, that's what you saw, right?
That actually
Good work.
makes sense to me.
Yeah, that's good. I mean, good, that's
Now what
good.
about number 7?
Number 7 is back to graphing, right?
It is?
Isn't number 7 graphing?
Yeah.
Probably.
That's what we did, that's what we worked on yesterday some. Remember that? We did the wrapping thing and all that?
I'm sorry.
Because you guys were good.
I do.
And what I did yesterday too is your class video went up yesterday, if you saw it. It went up late because power was out. Power was out when I was trying to upload the video.
Yeah, we went, it went out.
Yeah, and I had to go, and so it wasn't till after 8 o'clock that I finally did it. But anyway, so we have this, I go ahead. Now this is similar to the way I showed you yesterday, right? And so I'm going to put x, f of x, and I'm going to tell you, Carmen, I'm going to tell you from experience that this notation sometimes messes people up. But what this is going to look like is you put -5 here and -1. That's what it looks like, okay? Does that make sense?
Yeah.
But do you see how easy it is to put them backwards?
Yeah.
It really is. It's kind of confusing, or it can be confusing. So now we go ahead and we go ahead and subtract. What do we get here? 5 and 2 minus negative,
-3.
2 minus -5.
-7.
I'm going to get 7, right? So m is equal to 5/7. And here yesterday we had y equals, somebody told me y equals mx plus b yesterday. Who was it? Was Emily or some Emily? Yeah. So we go mx plus b is equal to y. So which of these points would you want to use?
The bottom one probably.
I would use the bottom one. Why, Hannah? Why'd you use the bottom
They're
one?
both positive, so it'd be easier.
Yeah, just probably the arithmetic might be a little easier. Okay, so that's just how, you could do that. But so we want to put m, and we calculated m is 5/7, right? And x is 2, plus b is equal to 4. And so what do? We simplify this. what's 10 times, or 5 times 2? 10 sevenths plus b equals, how many sevenths do we have in 4?
0.
No. Boop. 7, 14, 21, 28.
28. Good, I'm glad that somebody actually said that besides Will. Excellent job, Kayla.
I mean, I participated.
No, you're doing great. Was that Kinsey you said?
Yeah.
Yeah, Kinsey, you're doing great, Kinsey. Okay, so now we go ahead and what does b equal to?
18 sevenths.
18 sevenths. So what is our equation going to be? Y equals 5 sevenths x plus 18 sevenths.
You're one of my favorite teachers.
Well, that's very kind of you to say.
She's lying.
She's I think she's angling for more test grade points. That's
Of
okay.
course.
She ain't gonna be.
That's okay.
Suck up.
No, that's okay. That's okay. That's okay. That's good timing. That's good timing on the comments. Because what it is, it's sort of a long week, and I hear comments like that, and what does that do for me? Helps me feel better about myself and all that. That's a really kind thing to
You're my
say.
favorite teacher also.
Yeah, that's really nice. All right, it's on camera. All right, beautiful. All right, so what do we do to graph this? What is the way we talked about graphing?
Rise on the run.
Rise over run, right? So we start with what? We start with
B.
the B, right? So where's 18 sevenths rank?
Way.
Where's 18 sevenths?
2.5 is.
2.5 something, maybe a little greater? Yeah. So let's go over here. Now Hannah was asking yesterday about fractions versus decimals. You were asking about that, weren't you, yesterday? And this is one where the decimalized version is going to help me out more, right? Because I'll have an easier time figuring out where to mark it. So what is our rise over run on this guy?
507.
5, 7, so we go up, right?
Up 5.
Look at that thing on top and use it to move up and stop. Almost done, but there's one more hop. So this is 5. Now use the run to move to the right. 1, 2, 3, 4, 5, 6, 7. Draw your dot. Are we done?
No, not quite.
Not quite. Draw the line to connect the dots. But draw. Arrows because lines never stop. And then we check the points here, right? And the line is a little bit off here. I didn't draw it exactly straight, so we can see how. So we go -5, -1. So we go -5, -1. So that's about right. It's just because the line was drawn off a little bit, right? So -5, comma, -1. And then we have 2, 4, so 2, 4. So that's pretty close. 2, 4. But see, that's kind of a check on your work. So now we know this is a good equation. And where else could you check? You could check the second point too, couldn't you?
Yeah.
But this will be good. So what I want you to do is go work on number 8. And I tell you that when I give you your quiz on this next week, that I'm going to keep the fractions to halves and thirds and fourths. I'm not going to give any of this sevenths and all this business, okay? So go work this one out. I'm going to take attendance while you do that, okay?
I'm here. No, you're not.
You are here, but Adam says he'll be back on Monday.
Should be back in right.
Love you. How are you distracted by this?
Like that. Triangle. So
opposed to good job. How are you doing on this one, Carmen? You doing all right?
She's doing okay. I think she could be doing better. How you know?
It's all right. I see you guys working. It looks diligently to me. I'll say that.
Pretty diligent.
And using those calculators. One thing I didn't do, also I meant to hand out graph paper. Anybody need graph paper?
No.
Who needs, anybody need graph paper? No? No graph paper needed? Okay. I'm gonna watch and you can raise your hand when you're finished with this. So I want to know when you're finished with it, or also when you feel like you're stuck on this too.
Well, this is right. She's adding.
Mr. T, will you come check this?
I'll come over there, yes.
I am.
And the thing is, the reason I can check it is because I have, I think, within me a faint remembrance
Yeah,
from
see?
fifth period.
Stupid. You're so stupid. I don't care. I don't care.
I understand.
Is that 60 over 9?
Are you sure? I'm not sure.
So it's gonna be like, this is gonna be 23rd,
Oh, you want me to care?
Well, if you could, yeah. Is that 60 over 9? Yeah, so I think the 1% is right. That's just remembering the period.
How do you know?
It was,
I'm crying like a whole baby, right?
you got 36 nights, 35 nights for the 1%.
No, it's, you know, I'm
Just in thirds.
I will literally try
Oh,
to.
check out right?
In that trash can.
Oh, 14.
Ready?
Yeah, it's translated.
I think that is 14 thirds, yeah.
Yeah. So that,
Yeah, I think Angel got it right so far. Who else feels like they got it right? Feel like you got it right?
I can't.
She didn't, she thought it was a positive 7 to everything.
I can't even try because Kenny's so offensive.
Shut up. She already messed up.
I'm so
She already messed up.
We have theft going on in this class.
Me and Andy would like.
But we're still the
best class. No.
Right, this is, okay, this class has potential, yes. So, I'm not exactly sure how you did it, but, okay, if we have this and go -3, 5, I'll put x, fx, and then 6, -2. So then we have mx plus b is equal to y, right? And then we go like this. I'm going to get -7 over 9, right? So m, is that right? Equals -7/9. Is that what you got?
Yes. Carmen actually got positive 7.
I did not.
Well, here's what you could do. If Carmen got positive, here's what you could do. Carmen, if you got positive 7 over here, what did you get? You got -9 over here, right?
No, she got
Okay.
9.
I'm confused.
Because if you take 5, if you take 5 minus -2, that's going to be positive 7. But then you'd have -3 minus 6 and -9,
Oh, I get it now.
right? So either way, it's one, okay,
Bless you.
either bottom from top or top from bottom, the same way on each side, and your answer won't be rotten. Okay, pretend you're a baseball player, right hand over left. So anyway, We have mx, which point do you want to use here? Which one?
I use 6.
6. So m, we'll put negative 7/9 times 6 plus b is equal to negative 2. And what's negative 7 times 6?
I thought the negative
Negative
one was
42.
Negative 42
Yeah.
ninths
Okay.
9.
plus b is equal to negative 2. But can we simplify this? Yes. Negative, negative 14 thirds, right? Plus b equals negative 6 over 3, is that right? Or 6 over 2? No, you got 6 over 3, right? 6 over 3. And then,
Oh.
8 over 3.
so we have b is equal to
8 over 3.
8 thirds. So now we have our equation, yes. F of x,
B equals 2.6.
negative 7/9 x plus 8 thirds.
Plus 8
Yeah, that's what I got for.
26 for 15. Come on.
All right. So let's go ahead and graph this to see if this works out. Where is that going to go for y-intercept?
Like 2.6.
So about 2.6, right, about right here.
Yeah.
And then 8 over 3. 1, 2, 3, 4, 5, 6, 7. So 8 over 3, something like this.
No, it's negative 7 over 9.
Well, negative 7, I got the wrong way, excuse me. Negative 7. 1, 2, 3, 4, 5, 6, 7. So about here. And it's over 9. So that's going to be over here, right? So negative 7. So our y-intercept is going to be right here, right? So things going to go like this. I think this one's going to look better than the other one, provided it's right. I don't know if it is. So then our points will be negative 3, 5. So here's negative 3, 5. Does that check out? Pretty good. This other one's going to work better. It has 6, negative 2. 1, 2, 3, 4, 5, 6. Negative 2, yeah, it looks pretty good. Okay, now for those of you who got this, Emily, did you get this one right?
I got it right.
You got it right?
Yeah, I got it.
So a lot of you got it right. And those of you who didn't get it right, did you figure out where you got stuck on the deal?
Yeah, I'm trying to figure it out.
Okay. What I want you to do is go work out number 9. And also, I'm sort of thinking with number 9 being done, that we'll probably we're trying to keep the classes together.
Yeah.
So with number 9 being done, I think we can call class after that
I think it's good to me.
and have our concert.
Does Angel sing too?
Yes.
No.
Beyonce.
I'll sing for you.
He's a
I'm gonna sing.
What
Are
happened
we doing
in
karaoke?
what happened in first period today? Mrs. Walker.
Oh, yeah, I wasn't really the best at first period.
No, it wasn't, but
Oh, man.
the crowd was not very good.
Wow.
It was not a good crowd, was it?
I'm a good
But-
Yeah, I can't blame myself in first period.
But that other guitar player was good. Avery, he was a good player, right? Played, yeah.
Who was it?
Avery,
We have an Avery?
yeah, he plays guitar.
Oh, it's a.
He's a sophomore.
Yeah, lots of freshmen.
Okay, what I'm going to do is I'm going to. Are you finding you're doing better on these things here?
Yes.
Okay, I'm just going to quickly write this here. And help me out with this. What goes here? X, f of x.
Negative 4 and 6.
So negative 4, 6, and negative 1, 2.
Your slope.
and
is
subtract negative 4,
Negative
4,
3.
3. So m
What's it?
equals negative 4/3. So now we have mx plus b is equal to f of x, right? So which one do you want to use?
Negative 1.
Negative- Negative 1, 2, yeah. So we're going to have mx, we have negative 4/3 times negative 1 plus b is equal to 2. So what's negative 4 times negative 1?
4.
So we got 4/3 plus b, and how many thirds do we have in 2?
Whoa, time out. How did you wait?
6.
Never mind, you're good.
No, you're not.
And then we subtract, what do we get when we subtract here? 2/3. So b is equal to 2/3.
Oh wait, I thought 3 was over negative 4.
If you get it wrong.
Carmen, you can't even add, shut up.
Yes, we can.
So we have f of x
Never mind, I get it. No, you don't.
is equal to negative 4/3, right? Plus 2/3. There we go. And now to graph this thing, we go where? To 2/3. And then we go to negative 4, 2, 3, 4 in thirds. And so it's going to go between here and here, right? So something like this. Does that look right?
Yes.
And then we test our points here. We got negative 4, 6. Well, negative 4, 6, so that's, I didn't extend the line quite far enough, right? But we can still see that works out. Then we got negative 1, 2. That checks out, right?
Yes.
So this looks good. And so that's it. So was that okay for class today?
Yeah.
How many got number 9 right? You got number 9 right? Okay, good. So we're coming along. So we're gonna go ahead and resume on this on Monday. Good. Thank you, class.
Right.